Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. Now, take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Regional Constraints by Bellamy, and here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 without repeats in any row, column, or box. We also have Renban, where purple lines contain a non-repeating set of consecutive digits in any order. So, for example, this could be something like 3, 5, or 4, because these three digits add up, are consecutive with each other. But you could not have something like 3, 6, or 4 here, or 3, 4, or 6, because 6 is not consecutive with the other digits in the Renban, which is 4 and 3. So anytime you have a hole essentially in the Renban, that's not allowed. You can't skip digits. So it could be something like 3, 4, 5, or 1, 2, 3, or 7, 8, 9, or 6, 7, 8, etc., etc. And that's how Renban lines work. We also have killer cages, where digits do not repeat in cages and sum to the small clue in the top left corner, if given. So, what that means is that these three digits must add up to 9. There can't be repeats in them, but that's acknowledged by normal Sudoku rules. And these three digits must add up to 12. These two digits can be anything, can add up to anything. So as an example, you could have something like 1, 4, and 7 here, because those three digits add up to 12. And that's how killer cages work. We also have thermos, where digits along a thermometer must increase from the bulb to the tip. So as an example, you could have something like 2, 3, and 6, or something along those lines, but you cannot have something like 2, 7, 6, because it's not continuously increasing from the bulb to the tip. 7 goes down to a 6 here, which is not allowed. And that's how thermos work. We also have crop key dots, where digits separated by a black dot have a 1 to 2 ratio. So for example, if this were 2, this would have to be a 1 or 4 to maintain the 1 to 2 ratio here. We also have German whispers, where along green lines, digits must differ from their neighbors by at least 5. So if this were a 3, this would have to be an 8 or a 9 in some combination, because the only digits that are 5 or more away from 3 are specifically 8 and 9 in normal Sudoku. So that's an example of how German whisper lines work. And the final rule, which is probably the most important, is the constraint regions, where each constraint type, so every rule here, Renban, Killer, Thermo, Kropke, and German Whispers, each constraint type may contain no repeated digits anywhere in the puzzle. For example, all Renban cells must contain no repeated digits. All cells connected by a Kropke dot must contain no repeated digits, etc., etc. So that's a very important constraint. So that means if you had, say, a 3 on this Renban here, this 3 could not appear on any of the Renban's other Renban cells. So that's actually a very important constraint. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, that constraint is very, very important. And the reason why is the first one that I see, excuse me, actually there's multiple ones here. There are 9 cells in thermometers, so therefore it must contain the digits 1 through 9. There are 6 cells which have a 1 to 2 ratio, have a black Kropke dot next to them. And there are only 6 cells that could be next to a black Kropke dot. So we know all those 6 cells must be unique. But probably most importantly, we have 2 killer cages, which add up to 9 and 12 respectively. But that means these are 6 unique digits. So these 6 unique digits add up to 21. Well, what's the minimum you could have for 6 unique digits? Minimum sum. It's 1, 2, 3, 4, 5, 6 added together, which is exactly 21. So you know these 6 digits must be the digits from 1 through 6. So this must be the digits 1 through 6. This must be some of the digits from 1 through 6. And you know in the killer cages, you cannot have you can't have repeats. So this cannot be 1 through 6 here. What can it be then? It has 2 other digits that are greater than it, so it has to be a 7. So this is 7, which makes this an 8, which makes this a 9. This is an 8 or a 9 here. One of these digits has 2 digits greater than it, so this must be 1 through 4. And same here, this must be 1 through 4. So this could be, this is greater than this digit, so this is 2 through 5. This is greater than that digit, must be 3 through 6. This is 3 through 6, this is 2 through 5, and this is 1 through 4 here. This cannot be 1 through 6. This cannot be 7, 8, or 9, so this is 1 through 6 here. This cannot be 1 through 6 because it cannot contain... these digits are all unique here, and they all see this cell. So this is specifically 7, 8, or 9. But this has to be not 7, 8, or 9. Therefore, this digit is 1 through 6. But the only digits you can have on a Ren band with 7, 8, or 9 are 7, 8, 9, 6, 7, 8, or 5, 6, 7. So this must be a 5 or a 6. Which means 9 cannot be here. So this is 7 or 8. This is either then 5, 6, 7 or 6, 7, 8. So 5, 6, 7 or 6, 7, 8 is here, which means one of these digits is a 6. One of these digits is a 7 to form it's either 5, 6, 7 or 6, 7, 8. So we have a 6 and a 7 along this Ren band, which eliminates 6 in this cage. Well, what's the maximum now for this cage? It's 3, 4, and 5 adding up to 12, which is exactly the sum. So therefore, it must be specifically 3, 4, and 5 here. This 3, and 4, and 5 eliminates 3, 4, and 5 in the rest of the cages. So this must be 1, 2, 6. This 1, 2, 6 eliminates 1 and 2. 1, 2, and 6 from the rest of the column. So this can't be 1 or 2. This is 3 or 4. This cell must be greater than that, so it must be 4 or 5. This cell must be greater than that, so it's 5 or 6 here. This 3 or 4 or 5 means this cannot be a 3 or 4 here in this 1 to 2 ratio here. Well, what other digits can then form a 1 to 2 ratio without a 3 or a 4? They have to be 1 and 2. So this is 1, 2. This forces this to be 6, 7, 8, 9. The remaining digits in the black Kropke dots must be 3, 6, and 4, 8. Well, this can't be 4, 8 because of the 8 in the box, so this must be 3, 6. This then has to be 4 and 8. This 4, 8 pair eliminates 4 and 8 from the rest of the box. This can't be 4. This can't be 8, therefore this is 9. This 3, 6 pair eliminates 3 and 6 from the rest of the column, so this cannot be 6 here, which forces this to be a 6. So this is 5, 7, or 8 here. We're not sure which it is. This is a 6, which means this can't be 6. If this were 5, 5 has to be consecutive with 4 or 6, but 4 can't be here because of the 4, 8 pair in the box. 6 can't be here because of the 3, 6 pair in the column, so this can never be 5 here. So this is 1, 2, or 3. The 1, 2, or 3 has to be consecutive with each other. And you can't have a 4 here, so this must be specifically 1, 2, or 3. 2 has to be one of these digits then. So this cannot be 2 here. We also know 4 cannot be either of these two cells because of the 4-8 pair in the row. This cannot be 1 and 2, and it cannot contain a 2 in the rest of this box. You also can't have a 6. So if you can't have a 2 on this Renban, you can't have a 6 on this Renban, what digits can you have? You could have had 7, 8, and 9, except that this requires a 7, so this can't be 7, 8, and 9. 1, 2, 3 is eliminated. 2, 3, 4 is eliminated. You could have 3, 4, 5. 4, 5, 6 is eliminated. 5, 6, 7 is eliminated. 6, 7, 8 is eliminated. 7, 8, and 9 is eliminated. So this must be 3, 4, and 5 for these 3 digits. Because again, you can't have repeats on any Renban line. This 3, 4, 5 triplet eliminates 3, 4, and 5 from the rest of the Renbans. So this must be 1 and 2, which eliminates 1, 2 in the rest of the row. Therefore, this is a 6, which means neither of these can be 6. We also eliminate 5 from the rest of the Renbans, so we can't have, this must be a 6, 7, 8 triplet, which leaves 1, 2, and 9 in the rest of row 9. So this is 1, 2, 9, this is 1, 2, 9. What about these 4 digits on this German whisper loop? Well, the only 2 lows possible now, since we have a 3, 4, 5 triplet in the box, are 1 and 2. So 1 and 2 must be on this German whisper loop. Therefore, 1 and 2 cannot appear in this German whisper line. So the only lows possible are 3 and 4. But 1 and 2 can only be with 7, 8, and 9 here. So we have 1, 2, 7, 8, 9. This can't be 8, and this can't be 9. But where's the 5, actually? Well, that's probably not useful right now. What digits are remaining in box 1? We have 3, 5, and 6. This can't be 6, so this is 3 or 5. This is 3, 5. This can't be 6. Where is the 6 in box 1? It must be here. So this is 6. Where's the 1 on these thermometers? It has to be here, because it can't be any of these cells. So this is 1. Where's the 2 in the thermometers? It has to be here. This is 2. So 1 cannot be here anymore. 2 can't be here. This can't be 2 because of the 2 in the row. So this is 1, which makes that a 2. This is 3, 5, or 6. That's fine. 1 and 2 cannot appear on this German whisper line. So we have to have 3 or 4 here. If this were 3 in the middle, which is the only low digit that could be in the middle because we can't have a 1 or 2 there, then it would require an 8 and a 9 to surround it. But that 8 and 9 would eliminate 8 and 9 from this loop. And the reason why you can't have a 6 on this loop is each digit on this loop is next to 2 unique digits on a German whisper line. And 6 can only be next to 1 unique digit on a German whisper line, which is a 1. So if you had a 3 in the middle here, and it was next to an 8 and a 9, the problem is that would eliminate 8 and 9 from ever being on this German whisper loop, and therefore the only high that's possible to be on this German whisper loop would be a 7. But then you wouldn't have another high to be next to 1 or 2 on this German whisper loop, which there has to be. So that doesn't work. So 3 cannot be in the middle here. Therefore, 3 and 4 have to be on the outsides. Since this is a high digit surrounded by 3 and 4, that requires this specifically to be 9, with 3 and 4 on the outside. Therefore, 9 cannot be on this German whisper loop. 8 has to be on this German whisper loop with 1, 2, and 7. 9 cannot be here. The remaining digits in this German, in box 6, must be specifically 6 and 9. So this is 6 and 9, this is 6 and 9. This cannot be 9, so we now have a 1, 2, 1, 2 pair in column or row 7, which eliminates 1 and 2 in the rest of the row. So this has to be a 9. What are the remaining digits in row 2? We have 3, 5, 6, 7, 9. These two cannot be 6 because of the 6 in the box. This can't be 9 because of a 9 in the column. We also have a 3, 4, 3, 4 pair in column 4, which eliminates 3 and 4 from the rest of the column. What are the remaining digits? They have to be 5, 7, 8, 9. 9 cannot be here. 9 can't be here. 9 can't be here. Where is the 9 in column 4? It has to be here. So this is 9, which makes that 6, which makes that a 9. 6 can't be here, and 6 can't be here. Where is the 6 in row 2? It cannot be any of these. It can't be here, and it can't be here, so it must be here. So this 6 eliminates 6 from the rest of the thermometers, which makes this a 5. That makes this a 4, which makes that a 3. Which makes that a 4, which makes that a 3. This can no longer be 5 because of this 5. This can't be 3 because of this 3. We have a 1, 2 pair and a 3, 4, 5 triplet in column 9, which eliminates 3, 4, 5, and 1, 2 in the rest of the column. So this must be 7 and 8 here. This can't be 7 because of this 7, so therefore this must be 8, which makes this a 7. This 7 eliminates 7 from being there. We have 5, 7, 8 remaining in column 4. This can't be 5, so it must be 7, 8. Where is the 5 in column 4? It must be here. This is 8. The remaining digits in row 3 are 4, 5, and 3, 4, and 5. This can't be 4 or 5 here, so this must be a 3, which makes this a 7. This can't be 7 anymore. This is 4 or 5, and this is 4 or 5. Well, this cannot be 5 because of the 5 in the row. Where is the 6 in box 8? It has to be one of these two digits, which eliminates 6 from being there. Therefore, where is the 6 in box 9? It must be here. So this is 6. One of these is 9. We're not sure which. The remaining digits here are 6, 7, and 8. But this can't be 7 because of this 7. Where can 6 be in box 5? Can't be here, can't be here. It must be one of these two digits, which eliminates 6 in the rest of the column. This can't be 6. Where is the 6 in box 8 now? It has to be here. So this is 6. The remaining digits in column 5 are 1, 2, and 8. So this could be 1, 2, 8. This cannot be 1 or 2 here. Therefore, it must be an 8, which means this can't be 8. This is 1 or 2. Let's see, where else do we have? This is 8. The remaining digits here are 4, 5, and 9, which can be any of them. We have a 2, 7, 8 triplet in column 7, which eliminates 2, 7, and 8 in the rest of the column. Therefore, this can't be 7 or 8. This must be 9. This can't be 9. We have a 1, 7, 8 triplet and a 3, 4, 5 triplet in column 8, which eliminates 1, 7, 8 and 3, 4, 5 in the rest of the column. Therefore, what's the last digit? It must be a 9. This can't be 9. This is 3, 4, 5 here. Two has to be one of these two digits. That's fine. We have 1 through 5 remaining in column 3. So this is 1 through 5. This is 1 through 5, but this cannot be 3 or 4. This can't be 5. This can't be 3 because of the 3, 6 pair in the box. This 6 actually makes this not a 6, so this is 3, which makes that a 6. This 3 eliminates 3 from being here. Where's the 3 in this Ren band? It has to be here. So this is 3, which means this can't be 3. We have a 4, 5, 4, 5 pair in row 6, which eliminates 4 and 5 from the rest of the row. So this can't be 4 or 5. This is 1 or 2. We have now a 1, 2, 1, 2 pair in row 6, which eliminates 1 and 2 from the rest of row 6. That leaves 7 and 8 in the rest of the row. And this can't be 8 because of this 8, so this must be a 7, which makes this an 8, which makes this a 7. Therefore, that's an 8. Therefore, that's a 7. This 8 means this can't be 8, so this is 7. 7 cannot be here. We actually kind of already knew that, but... And we have 1, 2, and 6 remaining. This can't be 6, so where is the 6 in box 5? It must be here, which makes this a 1, 2 here. The remaining digit, we have a 1, 2, 8 triplet in row 5, which eliminates 1, 2, and 8 in the rest of the row. Therefore, what's the last digit? It must be 4. And then these can be 1, 2, and 5 here. This 4 eliminates that 4, so this must be 8, which makes that 4 by normal Sudoku. This can't be 7 because of this 7, so this is 8, which makes that a 7. This 8 means this can't be 8, so this is 1, which makes that 7, which makes that 2, which makes that an 8. And this works because the 1 and 2 have to be next to 7 and 8. This 2 eliminates 2 from being... This 1 eliminates this from being a 1, so that's a 2, which makes that a 1, which makes that a 2, which makes that a 1, which makes that a 2 by normal Sudoku, which makes that a 1, which makes that a 2. So these can no longer be 2 here, and these can't be 2 or 1. Therefore, this must be a 5, which makes this a 3. This can't be 1 or 3, so this must be 4. This 3 eliminates that 3, so this must be a 5. This 3 also eliminates that 3, so that must be a 5, which makes that a 4, which makes that a 3. This 5 makes that a 9. This can't be 5 or 9, so this is 4, which makes that a 5. This 4 eliminates that 4, so that's a 5, which makes that a 4, which makes that a 5. This can't be 5 or 4, so that's a 3, and therefore this is 4. And we have here, it's 1, 2, and 3. This can't be 3, so this must be a 3. This can't be 2 or 3 anymore, so this must be 1, which makes that a 2, which makes that a 1. That leaves a 2 remaining in one of these cells, and this can't be 2 because of that 2, so this must be a 2 here. This must be an 8. This 1 eliminates that 1, so this is 5, and that's a 1. That's how you solve it. Yeah, pretty straightforward, especially with the constraint regions, right? You do have to have a little knowledge of how essentially certain digits work, particularly the cages, and that the minimum of 6 unique digits must add up to 21. But everything flows pretty well straight from that, right? So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.